Hello and welcome to SudoKanard. Here is a classic Sudoku puzzle which was created by Lucy Audrin and published on the Discord website server of Cracking the Cryptic. So I already made a solve of this Sudoku, but I made a mistake. I forgot some candidate in some cell, and although I found the correct solution, my solve was not valid. So I thought I had to make a new video to prove that I can solve it. So let's get cracking. 1, 1, and 1, that's a 1. 9 in one of those cells, 4 in here using all those, 4 in one of those, 3 somewhere here, 8 in this cell, 8 in this cell, 8 in one of those, then 9 here, so 9 here, what next? 9 in one of those, and actually 9 in this cell, because on the last row 9 couldn't go here, it couldn't go here, and it couldn't go here. Then 1 has to go in one of those cells, and somewhere here. Well, actually, those ones and those ones put a 1 in here. 4 in one of those cells. Now, on this last column, 4 can't go here, so it has to go there. So there's no 4 here. There has to be a 4 on column 9 and on row 9, and because of this 4, it goes here. And there's a 4 here and a 4 there. 1 in one of those cells. This is 2 or 7. 1, 2, or 7 in those cells. 2 or 7 here, 2, 7, or 8. We need 2, 4, 7, and 8 in those cells, and 4 is ruled out from those. 8 is ruled out from this one. This is 2, 4, or 7. 24/7, I guess. I would certainly do Sudoku 24/7 if I could. These 9s put a 9 here, and now 5 has to go there as a result of this one and this one. 1 comes in one of those cells, removing this possibility, and we have a 1 here and a 1 here. 2, 7, well, 6 is not here, 6 goes there, 5 goes here, and that's 2 and 2 or 7. 2, 7, or 8. Well, actually it's an 8. It's the only cell it can go in row 9. This is 2 or 7. 3 goes into one of those cells, and so does 6. This is a 3-6 pair. And actually, because of those digits, this could have been pencil marked from the start. We need a 5 somewhere in one of those cells. And two of those digits should go here. 2, 3, and 7 here. Seven does not go in this cell, so we have a 7 in here. This is not a 7. 2, 5, 6, and 7 up there. This is not a 5. On this row, 2, 5, 6, and 8. 6 and 8, this is 2 or 5. 2, 5, 6, 2, 6, 8, 2, 5, 6. I still need a 3 somewhere. On this row, 2, 3, 5, 7. This is 2, 3, or 5. 2, 5, or 7. Oh, that's not a 5. There's a 5 here. So we have a 2, 7 pair. That's a 3 or 5. And that is also a 3 or 5. 3, 5 pair here. What about this? We still need a 9. Oh, 9 and 9. As you would say in German. A 9 here, a 1 there, a 1 there. This is 2, 4, or 7. And we still need an 8 somewhere. It's not here. It has to be in one of those cells. And this, well, on this row we still need 2, 4, 7, and 8. So this is 2 or 7. There are a lot of cells that can only be 2 or 7. This one is 2, 4, or 7, making this an 8. This has 4 possibilities still. Where should I look? This column still needs 2, 7, and 8. Oh, this is not an 8 now. So this is an 8. And this cell. So we have just another 2, 7 pair. This is not a 2. And we have a 5, 6 pair. And this is 2 or 7. Providing another 2, 7 pair and another 3, 6 pair on this row. How will all of those interact? This is 2, 4, or 7. Those two 2, 7 pairs, they act as a skyscraper. There was already a skyscraper on Lucy's first classic puzzle. Those cells cannot both contain a 7. One of them has to not contain a 7. Therefore, one of those has to contain a 7 if you use those columns. So one of them has to be a 7. So this one can't possibly be a 7. And the same goes with 2s. If one of them has to not be a 2, so one of them has to be a 2, and this one can't be a 2, so this one is a 4. Now this is 2 or 7 again, and this 4 removes this 4, making another 2, 7 pair, and that's a 4. Well, is there anything more to gain from all of those 2, 7 pairs? There are so many of them. What about this? What more are we supposed to notice? Oh, there's a skyscrapers on sixes here, but I can't make anything out of it. What am I missing now? Is there any more to say about those skyscrapers? Not that I would see. Is it about the twos with this and this? No, I don't think so. What is this? Is it about... Oh, yes. Oh, that's it. That's a chain. The chain is here. It starts here, then it goes there, then there, then there, and there. Yes, these chains are always difficult to spot. So the logic is this. We have 2 digits, and let's say 2, 3, and then we have 3, 6. So the second digit is the first of the next cell. 2, 3, 3, 6, 6, 3, 3, 5, 5, 2. And the last digit is the first of this one. So what is the logic? Well, there are 2 possibilities. First one is, this one is a 2. And the story is just that. This cell has a 2. And the other possibility is that this one has a 3. Then it makes this a 6, this a 3, this a 5, this a 2. So in the first scenario, that's a 2. In the second scenario, that's a 2. So one of those cells, at least, has to be a 2. And then those can't be 2s. So let's remove. This is not a 2. This is a 7. That's not a 2. And that's a 5. And then the rest of the puzzle should basically collapse, making this a 2. The 2 7 pairs will be disambiguated. Oh, and that's a 3, making this a 7. That's a 2, that's a 7. Then we have a 5 here. We also have a 6 here and a 5 there. That's a 2, that's not a 2. That's a 2, that's a 7, a 2. This one is a 2 as well. And how are we finishing this? Those cells must contain 3 and 6. So now this 3-6 pair makes this a 7, this a 3, that's a 6, that's a 7, that's a 3. And all of this just follows. A 5 here, a 6 there, and this time I think my solve was fully correct. And it was much more sophisticated than what I thought on the first try. So I'd like to thank Lucy for this very nice puzzle. I'd like to thank Dipanshu Shukla for pointing out my mistake in my first video. And thank you for watching this video, and see you soon on SudoKanard.